Day 23, Cost Optimization, Batching, Caching, Model Choice. This is the day where AWS stops asking whether your GenAI system works and starts asking whether it can survive finance. Because in the real world, systems don't get shut down for being inaccurate. They get shut down for being too expensive. Imagine this. A company launches an AI platform for internal use. It summarizes reports, answers policy questions, runs an operations agent, adoption explodes, everyone loves it. Then finance sends one email. Why did AI costs triple this month? Nothing is broken, nothing is unsafe, nothing is inaccurate, but the system is wasteful. That's the day 23 problem. To understand cost, you must first understand where it actually comes from. There are 5 real cost buckets in GenAI systems. Input tokens, your prompts and retrieved context. Output tokens, what the model generates. Model choice, big brains versus small ones, embeddings and vector storage, and repeated, unnecessary calls. If you can shrink even one of these buckets, cost drops. The biggest lever by far is model choice. Here is the exam truth. Using the smartest model for everything is almost always wrong. If the task is shallow, repetitive, or predictable, rewriting text, summarizing, classifying, formatting, you do not need a thinking monster. You use cheaper models. Titan TextLite, Titan Text Express, Claude Haiku, they are fast, they are cheap, and they are good enough. You only use larger models when reasoning or accuracy actually matters. Complex RAG answers, ambiguous decisions, policy interpretation, that's when Claude Sonnet or Mistral Large earns its cost. AWS does not reward overkill. A very common exam trap is this. Use a larger model to reduce hallucinations. That is almost never correct. Hallucinations are fixed by retrieval quality and grounding, not by buying a more expensive brain. Once retrieval is correct, you pick the smallest model that still works. The next major cost sink is token waste. Tokens are money. And tokens are wasted in very predictable ways. Long system prompts repeated on every request, retrieving too many chunks, passing entire documents instead of small sections, verbose answers when short ones would do. This is where token discipline matters. You cut token costs by being intentional, short, reusable system prompts, lower top K retrieval, re-rankers instead of more context, clear instructions to answer concisely, strict grounding so the model doesn't ramble. AWS loves the phrase token budgeting. Now let's talk about one of the cheapest wins in the entire exam, caching. Caching means you don't recompute the same thing twice, and GenAI systems repeat themselves constantly. You can cache embeddings, almost always, RAG retrieval results, final answers for common questions, tool call results in agents. Anywhere the same input produces the same output, caching saves money. Picture this. Users constantly ask, what is the expense policy? That policy changes maybe twice a year. Without caching, you pay for retrieval and generation every time. With caching, you answer once and reuse it. That's massive savings. If the exam mentions frequently asked questions, repeated queries, static documents, your brain should immediately say, cache it. Next is batching, which is incredibly powerful, but only in the right place. Batching means processing many items in one call instead of many small calls. It shines in offline and high-volume scenarios, generating embeddings for thousands of documents, daily summarization jobs, bulk document processing. This is where batching slashes cost. But batching is not for everything. You do not batch real-time chat. You do not batch interactive agents. You do not batch low-latency workflows. AWS will penalize you if you suggest batching where users expect instant responses. RAG systems deserve special attention here. Most RAG cost problems come from bad retrieval, top K too high, no metadata filters, re-embedding unchanged documents, rerunning the same searches again and again. The fixes are retrieval fixes, not model fixes. Embed once and reuse. Filter aggressively. Cache retrieval results, tune chunking and overlap. Better retrieval means fewer tokens and fewer retries. That's real cost control. Agents are their own cost problem. Agents are expensive by default because they take many steps, call many tools, and generate long traces. But the correct response is not avoid agents. The correct response is optimize agents. You control agent cost by capping maximum steps, caching tool results, using smaller models for planning, and escalating to larger models only when necessary. AWS rewards this thinking. At the heart of Day 23 is one question. What is the cheapest architecture that still meets requirements? Not the cheapest possible, not the most accurate possible, the right balance. That is senior engineering. Let's call out the classic exam traps. Fine-tuning does not automatically reduce cost. One model for everything is lazy and expensive. Caching blindly creates staleness. Batching real-time chat is wrong. Every optimization is contextual. AWS wants thoughtful trade-offs. If you remember one decision tree, remember this. First, can I use a smaller model? Second, can I reduce tokens? Third, can I cache results? Fourth, can I batch requests? Fifth, can I reduce agent steps? That sequence solves most cost questions. Here is the one sentence to lock this entire day into memory. Cost is controlled by model choice, token discipline, caching, and batching, in that order. Say it once. Day 23 sticks. Final self-test. An internal RAG system answers the same policy questions repeatedly, and costs keep rising. What's the best optimization? Cache-grounded responses and reduce repeated retrieval. That's day 23 mastered.